Okay, some claim that the belief in the hot hand stems from the tendency of fans and athletes to misjudge the length of streaks that one might expect in randomly generated data. So here we have a table, and each column represents 10 outcomes from a simulation of an experiment where we gave the basketball player a 50-50 chance of making a shot. So essentially it's like flipping a coin 10 times. So we repeated that experiment 10 times, and we show the sequence of misses and baskets that the basketball player got in each case. And again, because we have a small number of trials of the experiment for each column, we ran 10 trials of the experiment. We have a small amount of data, so the chaos of small numbers is at large. And it gives us some idea of the length of runs of baskets and misses that we might expect in the output. And we can see there's a wide variety. You can see in column 5 that the player missed the shot 6 times in a row. And this was entirely due to randomness. Now, if we were watching the basketball player, we might say that they have the opposite of the hot hand. They might have the cold hand in that case. However, this string of misses was entirely due to randomness. In column 3, we have a string of baskets of length 4. And once again, we might think, in watching this basketball player, that there was a hot hand effect going on here. But in fact, this string of baskets of length 4 is entirely normal in randomly generated data. So looking at this, we need some idea of what to expect in randomly generated data for a small number of shots. We can't really judge whether a player has the hot hand or not based on 10 trials of the experiment. And going forward from here, we would like to get a handle on what lengths of runs to expect in a large sequence of shots and misses for a basketball player with a 50-50 chance of making a shot.